Hey Mehul, how are you doing?
I'm good, Srinivas. How are you?
Good. So you hear the little one. How old is he now?
Hey, it's almost 2.5.
Oh wow, 3 years old. Huh?
Yeah, we had gone to India, so I was away for a while.
Oh, so
But
you just got back or something, or
yeah, we got back mid-Feb, but just then everybody got sick and jet lag and all the usual stuff.
yeah, travel with young kids is tough.
Yeah, and we took the direct San Francisco Mumbai. It's like 17 hours direct.
Oh
Uh,
man. Mm.
yeah, and that was his first ever plane ride.
Which airline does it? Air India does it? Or
Siri was listening or trying to do some summary. Don't know what happened.
it's kind of it's a good age. I think
Yeah.
grow up really fast and start having, you know, their own opinions where they don't want you around. So
How's this competition so far? Is it interesting? Like time series data,
yeah,
right?
it's not really. It's kind
No?
of
Okay.
more of a image. That's what I originally, um,
Oh, image. Okay, sorry, my bad.
yeah, it's more of an image.
Okay. Hey, Steve.
Hiya, how you doing?
Good,
You haven't
good.
been online in a while?
Yeah, I was
Just
just telling Srinivas that we'd gone to India for a month, and then we came back mid-Feb, and
all right.
flag. Yeah,
Been on
Guys,
holiday?
yeah, just to like the kid hasn't seen his grandparents, so he met all the family for the first time.
All right, very good.
Yeah,
More like they met him, not that
they
he'll
met.
remember anything.
Yeah, yeah, he just. Yeah, and then the
Good.
flight was 17 hours direct, so that was fun.
17 hours?
Yes, San Francisco to Mumbai. I recently
Right.
found out. Yeah, it's there's an Indian Airlines called Air India, but it turns out because India is friends with Russia and Iran, so Indian planes can fly in Russian airspace, but like American planes cannot. So,
Do,
so
do you need
none of the
do you need to fly in Russian airspace to get to India? I thought it was
yeah
the wrong
it
direction.
yeah I don't know why somebody was telling me about that like uh, yeah one of my friends who was looking at that he was like um, somehow it's like how the jet streams are and how it makes it easier if you go in certain routes,
All
so they don't do a straight line, or like
right.
they
So I
they
thought they'd just go straight across, whereas I thought if you went by Russia, you'd be too far north.
yeah I don't know why. Yeah, that's true. Yeah, you're right. I don't
Yeah,
know
in
why.
fact, that in itself is a fascinating detail that, um, you know, I just for a long time I didn't quite get that, and then there's if you I don't know if I find it, I'll post it on Slack just out of curiosity. But the way it works is if you actually go, in fact, there is this puzzle question that if you turn east from Seattle and keep going east, what's the first, after you pass the US, what's the first land mass that you hit? And the answer to that question is what answers what we are discussing here. Why do you fly in an arc, and why is an arc, like going up above the north, not necessarily for the north pole, but the arc of uh, getting from point A to point B on the Earth is usually the shortest distance is an arc, not what we view as a straight line. And the way it works, apparently, it requires a little bit of a mind-bending thought exercise. But the answer to the question of if you keep going east from Seattle after you leave the US, what's the first landmass you hit? Is of all things Australia. And the
Right.
reason for that,
Whoa.
yeah,
If you go east,
it's yes, if you go east. you hit
I mean,
after
west?
you leave the US, not west. If you go east, what's the first landmass you hit is Australia. And the reason for it is if you continue to keep going east, then you won't follow a latitude, because if you follow a latitude, what you're actually doing is you're constantly correcting. If you follow the same latitude, you're constantly correcting yourself to keep going north. Then if you just keep going east, it's strange, but there's grass and stuff. That's why I said, I mean, it took, and I still, I'm digesting it, so to speak, but it is true that if you keep going east, pure east, and that's where it's confusing, because typically when we think of east or west, we think of kind of keeping on the same latitude. But if you keep on the same latitude, you're actually correcting yourself constantly and moving north. You're not always following east, which is itself quite puzzling. So that's among the reasons why, or probably the reason why, the shortest distance from the Earth between points is kind of a curve, not what we imagine on a non-3D space to be a straight line. So it's kind of weird, but that's...
Yeah, I've noticed like if you're flying from, I don't know, say like America to the UK, you go pretty high up over Greenland or whatever.
Yes,
But yeah,
exactly.
didn't think if you were going to India, you'd go over Russia. I thought that'd be too far.
Yeah, well, it's almost like you when you fly from Seattle and you take one of these nonstops, then you kind of go up north and then kind of quote unquote fall down, so to speak, kind of go up, like you say, still follow to Greenland and stuff, and then come down through Europe. But it may be that you go further east and then descend down across Russia down to. That's why you might probably cross into Iran airspace too. But I'm not sure. I mean,
I'm not sure I'd want to be crossing into Iranian airspace at the minute.
Yeah, but actually many airlines fly over Iranian airspace anyway, because of it's a vast country.
Yeah.
So we don't even know what all we cross in terms of airspace. I mean, I guess until something like the Korean airliner, which was shot down in the 80s, happens, they're like, oh shucks, guess better take out or something. I don't know whether you guys recall, but I was in the US then, and that was a crisis. Russia literally shot down a Korean airliner of 200. Anyway, on to more mundane things. So, Steve, I saw you had gotten to 0.33. So, what things did you do beyond what we discussed of using that notebook? And then you zeroed. My recollection is you stuck with init B0, then you kind of, like I shared, that you increased the fold to 10, and then you also had zeroed the whatever the augmentation that he was using, and instead of doing 0, 1, 2, 3, 4 until 7, you just use 0 for that. Did you do anything beyond that?
Yeah, so I can't remember the name of the guy. There's like one guy at the minute, he's been like releasing ensemble notebooks. He's the one with the highest public score at the minute. He had one that was like 4 notebooks, and he's like gradually sort of improving on those. I noticed now that he's just released another one, which is even better, but it only gets 0.34, I think. And he's put like 7 models in it. So I took that notebook, and then, yeah, like those are all basically derivatives of the Chris Diot Keras original spectrogram thing. So yeah, so I've added into it. Then there's the PyTorch one, which is the one we were talking about last week. So yeah, by adding it into his ensemble, because it gives me the best results, and it yeah, so like that's what it said last week. So I slightly changed the augmentation so as it put 0 in, and yeah, I had trained it for 10 folds, which gave me the best cross-validation score. But like actually, when I took those models and put it into my Kaggle inference model, it was worse. So I'm not
really?
actually using
Meaning when you ensembled, or just when you ensembled, or just those 10?
I only tried it in the ensemble, but yeah, the ensemble ended up worse. So maybe I should try the 10 by themselves, but yeah,
yeah,
I'm
because
not sure.
Just to give you a reference point, I tried multiple versions. I tried a ENET V0, a ENET V2S, and I also played around with one thing which I had mentioned to you before, which is, instead of taking, when he does this non-duplicate thing, or by dropping the duplicates, the guy who does it keeps the first if you have a bunch of duplicates. And I changed it to keep the last instead of the first. Now, when I used ENET D0, the difference between, I kept all the rest of it the same, 10 folds, the augmentation of 0 for all those 3 random cases, and then ENET D0, but I flipped the actual spectrogram I used from the choice of the first to the last. And for ENET D0, it remained the same, and I got about 0.35 with just either of them, 0.35 score for both, just with 10, just with those 10 models, 10-fold models. But then, interestingly, I saw that the original guy had done it with B2, ENET B2. So I switched to ENET B2, and I kept the choice of the last. And just with this 10 folds, I got 0.34.
Right.
So now I'll look at, and I wanted to kind of, as we were discussing right before, get just with this. The nice thing, as you also mentioned last week, is this guy just with overlapping the two, meaning the Kaggle spectrogram and then the non-duplicated label ID based EEG spectrograms converted, or EEGs converted to spectrum, we was able to get. So I was able to get to 0.34 with just what you had suggested in his base notebook. I haven't tried the ensembles yet. The other thing which I've noticed and which I wanted to try, I was wondering, whether you had gotten to 0.33 with that kind of approach and stuff, was, as I mentioned to you folks last week or week before also, it's kind of interesting to me that when I've seen consistently that when, at least, not in this approach of combining the two, combining the EEG and the Kaggle spectrogram, but when you do it separately, if you don't group and if you don't stratify by the expert values, and you just break the folds apart by just an index of 10, just 10 folds without grouping, without stratifying, interestingly, those scores, at least for me, were consistently better. So I'm thinking I want to try this approach with the guy's notebook as well. Stick to 10-fold, stick to the augmentation, but then don't group, don't stratify, and see what the results are. See whether they get any better results. Anyone there?
Yep. Yeah, so like, as I say, I've got to 0.33 by just ensembling and ensembling sort of the public notebook. And yeah, so like in the PyTorch one I have, yeah, so it does the double training thing where it trains on all of the data, and then it trains a second time, I think, on like the data that has more than 10 experts voting on it. And yeah, like there is a Keras version of the thing. I think it was like the original one. It does it slightly differently. But yeah, but like either way, yeah, so the best models I'm getting are sort of 0.34 by themselves and then 0.33 when I ensemble them. Whereas if you look at the leaderboard, you can see that like Chris Diot and stuff, they're much lower scores than that. They're what? Yeah, so Chris Diot's at 0.25 now. So yeah, so I've been trying to sort of do some detective work to try and find out what he's doing, because he must be doing something different. And I noticed that there's a discussion about external data. So I've been looking into that.
On that note, the one thing I wanted to draw all of our attention to, I haven't used it yet, but one of the guys who originally pioneered, I forget, Steve, he's actually an MD, I think, Dr. Steve something. And if you look at one of his notebooks, if you search for, since you're there, if you look for his notebook at Dr. Steve, somebody or the other, he's, actually, he doesn't say doctor, but just search for, is it,
That's me.
Just actually, if you go down, scroll down.
These are sorted by hotness. Is that what you?
No, by score. But his he's the guy who originally pioneered this training twice. Search for train twice or something.
Oh, is this bloke train twice?
Yes, that guy, Sean, not Sean. So if you look at his notebooks code, one thing he points out, which I thought was interesting, go to missing data in spectrograms.
This one?
Yeah. So he, in that, points out something very interesting. He says that like 7.2% of the label IDs are missing data in the offset spectrogram, and 8.7% of spectrograms are missing data in at least one of the offset spectrograms. And by missing data, it literally means that it's just blank. If you scroll down, yes, examples you see there, just like gone. There's nothing there. So what I was thinking is it would probably be interesting to see if there is any overlap when we select the spectrograms of this choice. And, meaning, are we selecting any spectrograms which have this blank problem and the offset is such that it's blank? And can we drop them from the training that we are doing if we're using it in training and or validation? And would that improve our score somewhat?
Yeah, this here is like quite similar actually to the augmentation that's used. The augmentation blanks areas, if you set it to 0 anyway, although it's not blanking as wide as that. It's blanking in strips.
Right, it's correct. It's strips rather than the whole thing, right? And in this case, if it's blanking that much, then it could be the case that when you take this is a spectrogram, right? So it's a 600. So when you take, the whatever 50 millisecond equivalent or the 600 second equivalent, then it might be completely blank, in which case those models, I mean, it's a small fraction when it says it's only 7% of the overall number, but I don't know how many of those spectrograms sneak into our training data, right? And by cleaning it up, I was thinking that maybe things could improve a little bit.
Yeah, so I'd seen that one, but yeah, like I was looking at somebody published a notebook with external data seizure data.
Interesting.
Not sure where it's gone. Yes, so they put there was a whole like external. Oh, I know how it was. It was like it was the guy who's been publishing the sort of the winning thing. I think it was this guy. He published, and like it was like a whole other data set, but it was just seizure data. So me just look at I added it into my stuff, but it didn't actually give me any better. But then through his thread or whatever, I found there's like another set of data, this Spark data. This here is actually this SparkNet thing. It's where the original training data has come from. And you can actually go to SparkNet and they've got like a whole model within here, like a PyTorch model, and there's a whole paper about it. And it was in the discussion. Yeah, this SparkNet data set. Yeah, so I got that. It's like and it's identical to this data. It's got like exactly the same sort of experts voting or whatever, and their model is trying to classify it. But like according
and
to
does it have EEGs and spectrograms, or is it of one particular type?
No, it's just the EEGs, and it's like 10-second window EEGs, but it has exactly the same labels. But yeah, according to this, he's like sort of saying that it's not the data that's used for the competition, but it's like 56,000 extra samples or something.
So have you incorporated this data, or?
I've just got it. I haven't put it in yet, but
And how would you combine, given that they are of different sizes, like 10 versus 50 seconds?
Well, yeah, I'm not sure yet, but obviously I can take the Kaggle training data and like just like take the 10-second windows with it. So I could train a model, or I could even use their model that they have already. And yeah, just make it like a model that uses like the EEG data from the competition, but yeah, combine it with this 56,000 extra training samples where I have the labels for it. And so yeah, like just by sort of doubling the size of my training set, maybe get something better out of that. Yeah, like as I say, part of the reason I'd found it was by going into Chris Diott's discussion list or whatever and see what he'd been talking about. I'd like to see, could I find out what's giving him such a big boost in the leaderboard? Yeah, so he's doing that. The other thing I noticed he'd been looking at is somebody posted a model about I think it's actually the people from, what do you call it, Albumentations, if that's how you say it. Saying they've got like Mix-Up. They've just added it into the thing.
Yeah, that was one of my things I was going to try as well with our approach is, can we use, or actually I had noted 3 things. I don't know whether all these 3, but I wanted to kind of get back in touch with them: label smoothing, cut mix, and mix up.
Yeah, this notebook here, this Mix-Up augmentations. So yeah, like they just like say it's just been added into the most recent version of this. And yeah, like I noticed in the discussion, Chris Dihalt was like saying, "Oh, that's really good." So I don't know, as he added it into his to improve things, but
yeah, no, I think combining this with the implementations we are doing of the zeros could potentially help. But interestingly, I don't know whether you ran into this, but I did for sure. As I was trying to run, the same thing we're talking about of the guy, like the 2-level training and all that. And then so I did that, and I went to inference, and I ran the inference on the first model I trained, and I got a score of like 2.05 or something. I'm like, what went so wrong that I'm getting a terrible result? And it turns out that the guy was playing around with test time augmentation, and that was the version of inference that I had kind of started off with by mistake, rather than his previous version, which didn't have test time augmentation. So as soon as I fixed that, then my score got to 0.35. But just a heads up that if you branch off of his latest, he's playing with test time augmentation there, and test time augmentation seems to really tank the score. But that's another interesting idea, right? Like, why would it tank the score so much? And is there something there?
Was that this guy? Because
No, it was
his
the
notebooks are sort of
original.
changing all the time. He's the one at the top, but yeah, like you have to watch which version of his notebook you take because it's like
Yeah.
constantly changing all the time.
No, it was the guy who, the other guy who had the best scoring um, PyTorch combination of the EG and two-level training guy. If you go down, he's at, I think, 0.36 or something. That guy, the HMS efficient net video inference.
Yeah, it's the one I've been doing most of my work with.
Right,
Yeah,
right. So it's now version 3, right? And in version 3, he's actually doing, you see his score, 2.96.
Oh, right.
So I didn't see that. And I just like took his version 3 and actually version 2, if you go one. But this is the annoying thing about Kaggle is if you go one version down, it doesn't, I mean, immediately tell you, it gives this weird view that you can kind
Yeah.
of branch off, edit my copy, but it doesn't tell you what the heck the score of that is. Or at least I couldn't see it easily. But that's the one where he gets the best.
Yeah, it's the one I've been using. As I say, like so
Yeah.
he gets the 36, but yeah,
Yes.
that's the one that I've modified a bit.
Yeah, I followed your lead and got to 0.34 now
Yeah.
with just that.
Yeah, so can't remember where it was, but
Pretty good notebook.
yeah, no, like, and I'll just say he does like yeah, I think it's the best notebook there is so far, but yeah, like not many people seem to. Oh yeah, so like there's where he's doing the fill value.
Yeah,
So
yeah, yeah.
if you fix
Right.
that, then you get it.
Yeah.
Yeah. So, but he does like the two stage thing, whereas like
Right.
the other notebook does slightly different. Yeah, and the
He is
final
doing
notebook.
TTA here. See, if you can see his current version, he does the TTA.
Right. All right. Is that where he's doing this? Yeah.
Yeah, the TTA stuff. And the TTA stuff really kills the score. But,
All right.
something to think about, right? Like why or, how come the model is, so fragile or whatever that when you do anything like this, it just completely tanks.
Yeah.
But
I know you'd think like because the fact it's been trained on those ones that you could sort of take an average and get a better result, but I hadn't noticed he'd done
yeah,
that. I haven't taken this version.
right.
The other
Yeah.
notebook
So
I'd seen
I
was
mean,
yeah, I saw this notebook. It's like somebody talking about yeah, like they put the thing in a loop or whatever, and they use some student mechanism to come up with like redoing their labels. It sounded quite interesting, but I haven't got around to. I
yeah.
don't know
In fact,
anything about
the
label smoothing and training.
right. That was I hadn't seen this. Thanks for pointing it out. I'll definitely take a look at the other. But where I got this label smoothing and especially now that you mentioned student whatever, because the prior guy I mentioned, the PhD guy, if you go back to his set of notebooks, his name, what was it?
Was it this one?
What was his name? Guy who he discussed pioneered the two-stage training.
This guy. Yep.
Yes, that guy. If you look um, in his set of notebooks, this one, but just the one notebook where he says,
Oh, this here's the thing I was talking
he's
about. he's the one with like he's got the whole. He found like another external data source that's just on seizures, and so yeah, he adds that into the training thing. But I added it in and he got a better result. I got way worse, but maybe I was adding it into my model, so I didn't take his.
If you go down, you look at the noisy student class.
Is that not just like taking
So,
Chris Diott's notebook and like adding noisy student weights on it?
yeah, what is this noisy student weights? What does he mean by that? I just saw it. I haven't spent time on figuring out what it does. So what does this noisy student weight do?
Well, it's just the initialization, isn't it? So like, yeah, here. Yeah, so like here's where he's making the model. So in this one here, like it's sufficient net B0. And if you look at Chris Diott's one, so yeah, like he uses efficient net B0 as well. But here, when Chris Diott loads the weights, he loads in, what do you call it? ImageNet weights, the standard ImageNet. Whereas like this is like another one, noisy student, which I'm not familiar with. But yeah, so it's just like initializing the model weights to noisy student before beginning training. But I don't know what noisy student is. I've heard of it, but can't remember.
Yeah, so that was something I was, also, I mean, of course, we don't know whether it will, but it's worth trying that approach with our current thing too, right? With the efficient at B2 and just seeing whether the noisy student weights gives us any better results.
Yeah. Have you been training your models all on Kaggle, or are you using Colab?
No, I can't. At least I couldn't, because of, as soon as I did 10 folds, the thing ran out of memory. So I've been training it on Colab. How about you?
I was mostly doing, I ran out of GPU time on Kaggle, so I had switched over to Colab. What I found though, like, was when I took my best model, the one there I was like talking about before, the PyTorch one. When I train it on Kaggle, I was getting much lower CV scores. When I trained exactly the same one on Colab, I got like quite a bit worse. And like then just at the end of the week, I tried just like changing the seed on it, and changing the seed made a massive difference. I ended up with like a better model than I had in Kaggle. So the seed that's used on Kaggle doesn't seem to be very good on Colab.
Oh, interesting. That's very interesting because I have been so far, I've used the same seed as what, and this was one of my points that I jotted down saying, does the seed make a difference? So you're saying the seed does seem to make a difference.
Yeah, it made a lot of difference for me. Yeah.
Okay. Worth trying for me then. Changing the seed. Wait, this guy uses 2048 or something. Is that right?
I think he uses 2024.
2024. The other thing that I was, 2024, right there. Right there. Yeah. Seed equals 2024.
Oh, right, yeah.
And you're changing to something?
I changed to 42, and 42 gave me good results. But yeah, it does seem very, very temperamental.
Yeah, I know. That's kind of weird, isn't it? But then again, it could be the case that the augmentation through the random, because the augmentation is random, right? So the seed for it could make a difference of where it augments and where it doesn't. Good catch too. I want to try that. But how long does it take for you? I mean, for me, in fact, I couldn't train the bigger models like B0. I could train on only in Colab. Were you able to train B0 with 10 folds on Kaggle?
Oh, I didn't try that. I only did it on Colab.
Okay. Yeah, because I did try it and it just failed. It ran out of memory because I think the Kaggle GPUs are even weaker than the V100 because I was able to train the B0s with the V100, but I couldn't train a B2, just a heads up, with a V100. You have to go to a A100 to train the B2 model just so that you don't waste your time. Because the other thing we have to do, right, in this thing is we have to download and unzip, and that itself takes, I don't you get into even training the model. So I did all that and then ran out of memory when I used a V100 with a B efficient at B2. So I had to like step back and go A100, and A100 is harder to get. So I have to like keep trying. Okay. And then suddenly I get it either early in the mornings, my time, or late in the evenings, my time. So
Right.
it's like, I think during work hours, there are a lot of people on Colab banging away, and it's very hard to get a
I had
yeah.
a
So
quick
there are some
question.
good ideas to go ahead, Mel.
So in the EEG data, generally, just to understand how, I saw those images. So it's generally 1D signals, so they've just been stacked together to make an image. And then we are doing the traditional computer vision to on those 2D images.
They've been turned into spectrograms. So yeah, like the EEG's got like 20 channels on it.
Okay.
And then there's like some a banana model it's called, where you subtract 5 of them from each other to get like a signal, and then you turn it into a spectrogram, and then yeah, like as you say, then you use like just image processing, just standard conv nets on it is the
Okay.
approach at the minute. Some people have gone with the raw EEGs, but they haven't had as good results as the spectrogram ones.
Okay, got it. And these are
Yeah. So
20. Okay, yeah,
if you look at the Chris Diot notebook there is a Chris Diot notebook where he talks about his approach to converting EEGs to spectrograms, which pretty much everybody follows. There's a different set, just a heads up. There's a different, fundamental approach is the same, but how you get to the end result is slightly different with one bunch of guys. But the bottom line is that both of them convert EEG readings, and as Steve said, differential readings at different points on the head, and convert the tabular data of tabular EEG data into spectrograms. And then you have the native Kaggle spectrogram. Kaggle itself provides you native spectrograms.
okay.
And the approach we have been talking about, or the notebook we have been talking about, actually combines those two spectrograms into a single image.
Okay. And those machines from the different people, they all have like I wonder if you because it's not from one center, right? It's not from one machine. It's like data is collected across stations, across scanners.
Yeah, but I don't see that eventually it's all in the same table though.
In the same table. Okay. Okay. And okay, I'm just thinking. Yeah, maybe the
Eventually,
frequent. Sorry, there's some background noise. He's just singing some. He's singing Deep Blue Sea. I don't know why.
Yeah, that data I was pointing out, the SparkNet data, it's where the competition data has come from, and like within it is described better how they put the data together. So it said that it was like, I think it's like 18 different institutions and like several experts at each one, like and it said that yeah, first of all they gave it out to something like 20 experts, and like they sort of went through manually and like found areas within the EEGs that they recognized as like one of these 6 conditions or whatever it is, 5 conditions. And yeah, so like those experts, they manually came up with ones. And once they'd done that, then they said that they applied some machine learning thing and sent it to like a load more experts. And so yeah, like that's why within the data, it appears to be 2 distinct sets of sort of labeling. Like one of them has got like lots of experts have labeled it, and then some of the ones have only been labeled by a few. And I think that's why. So, and like that's why some of these models they train it in 2 stages. Like,
Okay, thanks.
the one other idea that I had, Steve, as you were saying, like, what are all the tricks maybe the guy is using? The one other thought that crossed my head, I am in another group that also discusses once every so often, some papers. And the latest discussion was on some paper that referred to weight averaging. So for that had to do with language model, but that triggered the thought that maybe one other thing we could potentially be doing is, I think we discussed this, right? Like if you recall, we had talked about this stochastic weight averaging of models. So instead of running inference post the getting the model done, the weight averaging or stochastic weight averaging, which by the way is natively supported on PyTorch, is what it does is it kind of takes the last 2 or 3 steps during training close to convergence and then averages those weights to get a single model. So I was wondering that might be something else to try with each of our folds.
And sorry, I had one idea about from the spectrogram. So like I don't know if anybody's done that. Like because the spectrogram tells you the frequency, right? Like it tells you the frequency distribution, but it doesn't tell you when certain frequency occurs. So there's something similar to that, it's called just short STFT, short term Fourier transform. So you do instead of doing but then you need to do the raw data and you go create it all the way. Yeah, but instead of doing it, yeah, you would end up with an image too, but just the images are based on like chunks of, so like every, whatever the time interval is, every 5 minutes, you do a spectrogram and then put it together. But that's been around like in signal processing for a while. And so many times you find like, um, because maybe when the frequency occurred in time is, it could have some signal, but okay, yeah, that's
But
just
that
an
is
idea.
related, but that is something we take into account here too, because if you look into the data gives you an offset into the spectrogram, and so the spectrogram itself is of, like, each spectrogram is of what was it, 10 minutes, so it's 600 seconds each, but the correspondence to the EGs is given by the offset, and then within the EGs itself, the classification labels that the experts have given is for the middle 10 seconds of a 50 second EG. And then that 10 seconds corresponds to obviously the corresponding spectrogram with a corresponding offset and stuff. So there is a time element to what we are doing with the spectrograms that we get natively from Kaggle or generate from the.
And you said that 600 seconds, 10 yeah, the, yeah, it starts somewhere in the middle. And how long is that? You said
No,
10
it
minutes.
goes from 0 to whatever the max offset plus
Yeah.
some delta, and for the spectrograms as well as for the EGs. And then the point is that if you get into it, go through the data steps, it's the middle 10 seconds of a 50-second EG that the experts are actually labeling.
Okay. And spectrogram, just to make sure I understand, is just Fourier transform of that chunk they're taking.
Yeah. So, if you see Chris York notebook or any other notebook, it will convert, it obviously lops off. It goes through the Librosa model, which is equivalent to the Fourier transform things you're talking about. Okay. I mean, it's like crossing an audio signal, right? So it's the same process that we go through to get. Yeah. And, the FFT and all that is generated through that process. Get the spectrum.
Yeah, I see. Yeah, maybe that's the clip they're taking is too small. But the whole point is like within that, when you take the Fourier transform, you will get frequencies. You'll see, okay, maybe whatever 10 hertz is max, but you don't know even within that. You could have two places where maybe the 10 hertz occurred at the start and at the end, but the spectrogram won't tell you like it was at different time locations within that window. So then so that there's been like, so that's why then people had like STFT, like have short-term Fourier transform. Even split that further, but then yeah, if it's that small window, if it's only 10-second window, maybe yeah, I don't know if it makes sense to split it more. Mm. Okay. Anyway, sorry, I just thinking about the data, but yeah, that's it. No more.
Mine were able to do anything last week?
No, I was quite busy this week, so I haven't delved into this Kaggle notebooks yet.
So what do you think of the weight averaging IGST?
Yeah, no, sounds good. Is that different from what was the other thing we looked at a while ago? Maybe it was the same thing. The thing where they add like noise into images. Was it WAG or something? Or it was a three-letter
I thought
abbreviation.
that was something different. Adding noise.
Yeah, like it was like we looked at it and like yeah, there was one competition where everybody seemed to be. There was a couple of competitions in a row where everybody seemed to be sticking this onto their images. I would have to look it up again, but yeah, it was like some sticking noise onto. But yeah, like in those competitions, it seemed to like improve things for people. I don't know. Does it help sticking that type of noise onto a spectrogram image?
Spectrograms, yeah. No, that's independent, orthogonal to what I was talking about, but that's an interesting idea too. It would be worthwhile to go check out. In fact, that's one reason I kind of forgot about it, but I think now might be a time to go back and reach into, when we did this word call thing.
Yeah.
Then what kind of augmentation we used. And similarly to your point, I do remember, because didn't we use something similar but in the language space for where we would add some noise? I remember Arto or somebody talking about that, and you actually had used it to improve the score as well. So the approach you're talking about, I remember vaguely adding noise or some kind of disturbance around the convergence point or something like that. But I forget what, like you say, I forget the name of the technique, but I vaguely remember that it was there, not just in images, but also we did it for language models too, or an analogous approach. So it might be worthwhile to go check it out. I don't remember the name either, but that's orthogonal to this approach that I'm talking, because apparently now, just as a side note, it's becoming quite, and it's quite the norm, or quite the followed approach of people squishing together weights of like Llama 2 and something else in the open LLM space. And then, squishing together a couple of 7 billion parameter models, and then getting a 13 billion parameter model and using that, and that gives better results on much of the output. I thought, wow, that's kind of really crazy. When you are actually munging weights of, independently trained models to create a new model. And the thing why people are doing it, it seems, is because it gives you better results while not having to pay the training penalty. So it's a GPU saving methodology, compute saving methodology. And I just saw that in some other paper, and I was like, oh, maybe we could do this simple thing of stochastic weight averaging to try and improve our score as well, which is just a simple averaging close to convergence of each of the models.
Yeah, I'm not familiar with it, but yeah,
So
that other thing is
go ahead.
the other thing. Yeah, it was a 3-letter acronym whose name I can't remember, but yeah, like people used it. You could use it to add sort of noise in the background to change the categories of images. So as you made like a horse come out as a dog or whatever in a classifier. But yeah, I can't remember.
Adverse, whatever, right? Like adverse perturbations.
Yeah, something like that. That's the trouble with everything having 3-letter acronyms. You can't remember which one was which.
Yeah, can't remember. Right. In fact, I don't even think if somebody asked me, there is a difference between cut mix and mix up, but I can't tell you what. That's like, well, time to go touch back on it, so at least we know differences, even if you don't end up. But given the pointer you add to the mix up, that will be so up on. Yeah, definitely we're getting to the point where we need to kind of continue to improve, because I don't think, like you, I also think that Chris and the 0.25 or anybody in the 0.2 domain is doing something fundamentally different than just getting there through ensembles.
Yeah, no, like they're so far ahead that they must have a different technique. Yeah, because the guy that's like doing the main ensembles, he's adding in like one more model and getting like a very, very slight improvement. He's not sort of getting above 0.33.
Yeah. So that's why I want to spend at least, like when about 2 weeks are left, then we can start just banging on the ensemble. But until then, I want to kind of keep hammering away at improving kind of the underlying approaches. And I think what we discussed are quite a number of, external data, then net data, the mix up with argumentation. Then this another idea is the noisy student weights, stochastic weight averaging, changing the seed, all these kinds of ideas are worth trying. And then we can, eventually cave to the link.
It'll be interesting when we finally finish and see that, if the top 10 are they used, like whether they use raw or spectrogram or something else, like, because spectrogram is only just one way to convert it, but maybe you could do like wavelet or something else. But yeah, it'll just be interesting.
Chris also has a wavelet thing, but it doesn't score.
It doesn't score. Okay.
1D. It doesn't score as well. He does have a starter wavelet thing, but and at least as Steve mentioned already, nobody that I've seen has any approach other than the raw data just does not get you there. So everybody on the thing is using spectrograms and EEGs, raw EEGs converted to spectrograms. So I don't think, my guess is nobody is going to get there with raw data, right? But it'd be interesting, as you say. Maybe, someone out there is getting close to the top with raw data, which would be, but my guess is like a lot of the top guys are just fundamentally doing something different. Then potentially even in the conversion, like you say, but definitely are using spectrogram to get there.
Okay.
That's my guess, but it's a guess. But fun competition so far. Because the more interesting thing is, what are all the things that people are doing as low score? I mean, remember that, when the competition started, it was at like 0.5 and 0.4, and now people are at 0.25. They've come a long, long way. Alrighty. Anything else?
Nope.
All right. Sounds good. Let's all one more round around.
Okay, so see you next week.
Yeah.
Okay.
See you later.
See you folks next week.
Cheers.
Bye,
Bye.
guys. Take care.